Okay, today is factored form to general form, but we're going to definitely do a lot more than that because that's factored form to general is incredibly easy. This is a review of vertex form to general form, and it's just showing you how you would have multiplied that thing out. Notice they get all of this part done, and the 3 still hasn't been added. Then they combine it together, and the 3 still hasn't been added. Why does it have to wait for last? Because of the order of operations. In the order of operations, you do all your multiplying and dividing and stuff first, and then the last thing you do is add and subtract. That's why that 3 has to be left for very last. And why would you even want to do this? Vertex's form is so nice. You've got the vertex. It's -2 comma 3. Why would I ever want this? It does tell me 2 important things. Number 1, it tells me the what? The y-intercept. Good. It tells me the y-intercept is 7 because the y-intercept is where? Fill in the blank. X equals 0. So if I put a 0 here and a 0 there, these cancel, and that's why the y-intercept is right there, because it's where x equals 0. Okay, last thought is it does tell me one more powerful thing. It tells me A, B, and C. A is 1, B is 4, and C is 7. Why do you care? Because those can go into the quadratic what? Formula. Okay, the quadratic formula is really, really powerful, and it solves and gives you the roots. Those are the last 2 missing things. We've already got the vertex from here. We've already got the y-intercept. Pretty much the last thing we care about is those, the x-intercepts, the roots. You can get them from the quadratic formula. All right. So would you take this one right here, and you don't have to get it, you know, this is not going with this. If it was, you could just look at the picture, but the picture does not match this graph. Would you please find the roots for this one? You've done it on the top 20 like 35 times. You know how to do this. And then find the roots on that one. By the way, when you're asked for the roots or the zeros or the x solutions or the x-intercepts, you should give your answer based on the kind of question you were asked. If you're asked a graphing question, then they want the points, like what comma what. If you're asked an algebra equation, then they want the answers like this. All right, here we go. Part A. This one can be solved. You say 3x minus 2 equals 0. Then you say 3x equals 2. Then you say x equals 2/3. Raise your hand if you got 2/3. All right, good. The other one is much simpler. That's just -3. I can just see it. Why? Because if I put -3 in, it'll make this equal 0. So -3 and positive 2/3. On the other side, we have -1, or if you needed it in point form, x is -1, and these are x-intercepts, right? So they are where y is 0. And so this other part has y equal to 0, and it's at 1, 2, 3, 4. There we go. -1 and 4. Any questions on those? All right, that should be the easy part. So now, just look at these real quick. Can you have just one solution? Is that like legal? Yeah, you can do that. It's the parabola just touching once right there. And it only has one solution, and that solution is -4. How would you write it then? If there's always 2 parentheses. Yes? Or, as you said, there we go. Does that make sense? Okay. Why do we write it twice? It seems like you should only write it once. Well, if I did write it only once, it wouldn't be a quadratic and it wouldn't make a U shape. It would just be y equals x plus 4. That's a line that goes through 4 and has a slope of 1. It doesn't look like that at all, right? So we have to have more than just x plus 4. It's a double root, like that. Okay, next up. There are 3 major forms. General form, which tells you, what's this thing again called? Y-intercept. Vertex form, which I don't know what that's good for. Gee, that's hard to tell. Maybe it's good for a hunting snipe? Nope, it's good for the vertex. And last but not least, the factored form is the one that's good for the zeros, the roots, the x-intercepts, the solutions. Okay. All right. Now, back to this one for a second. What's this A? somebody's not paying attention. With me, thank you. Okay, unplug and leave yourself unplugged. Thank you, good. That A right there, that A is a stretch factor. Do you remember that? So if we stretch it like a vertical stretch of 2 or whatever, that would mean that your equation has stretched vertically, vertical stretch factor 2. All right, that scale factor is going to come in today. And that, here it is again, scale factor. That it's unknown right now. But let's say I said scale factor was 3. And let's say I said one of my roots was 5 and the other root was 2. And that'd be the equation then. So write me the equation for both of these. Okay, here's what you should have said for the first one. I hope you have a y equals or you don't have an equation. Next, I hope you have a 1 in front. Even though it's kind of lame, the scale factor of 1 put right there shows that you know where to put the scale factor. Granted, we won't really need 1 if it's a 1. And then some people are going to say x minus 3. Why are they so wrong? I know it's the opposite because you can't trust the stuff on the inside. That's a good answer. Why would this 7 need this to be a minus 7? I'll give you a hint. What's its name? Starts with a Z. A 0. Very good. So if this is supposed to be a 0, then when you put it in, it should make the equation equal 0. And if I had a plus there, it would make it equal 14, and I don't need that. I want it to equal 0 right there. So you always use the opposite here and here of what you have here and there. All right, everybody make sure your part B is good, given what I just told you, and please compare it with the person that I paired you with for today. All right, we're going to go in the back. Mr. A, would you tell me what you had for an equation? You are very correct. Now, what if I asked you to give me general form? Tell me what you should do. Yeah, just FOIL it out. What's the last thing you would do in your foiling process? Multiply by 3. Good. Technically, just so you know, you could multiply this in first and then FOIL it. But here's the mistake. If you do that, a lot of people just keep going with the 3 and you multiply everything by 3. That would be wrong. You don't want to do that. You'd have to, that's why I say, I think this is an example of starting on the inside, because that is like the inside. Get that foiling all done with first outside, inside last, and then multiply by 3. All right, moving on to this one. Vertex form implies we need to know the vertex. Mr. V, what's the vertex on this one? What, comma, what? Excellent. Everybody use those 2 that he just told us. He was right. To tell me what the equation in vertex form is. And I don't want to show it to you. I want to see if you can find it without me. Y equals parentheses. Ooh, scary. That's looks like you were trying to write it in vertex form. Okay, go ahead. Exactly. Minus 4. All right, raise your hand if you had the same thing as he did. Awesome. Now, what's factored form? It does not just come from this. Unless you want to multiply all of that out and then subtract 4 and then take what you have and factor it, it would actually work. There's a way simpler way. Who can look at this graph and right away know what factored form is? Yes, ma'am. Yeah. Where are you looking, though, on the graph? Yeah. Awesome. Those 2 spots. And then they tell you the equation. What is the equation? Awesome. There you go. Now, what's one thing that I never even talked about, but could have totally gooned my answers? I had done them right, but I didn't even look at this. Stretch. Was this thing stretched? No, because the way I can tell for sure is I go over 1 and up 1, and I can see that it did not get stretched. If I went over 1 and there wasn't anything that 1, if it had gone like over 1 and up 2, I would have known, oh, there was a stretch factor in there. Okay, so watch for the stretch factor, and also watch for if it happens to be upside down. See, everything else would have been the same. Like it would have gone through these same 2 spots. And a lot of people miss it, and then they just don't even think about how, oh, it's got to be a negative because it's upside down. We didn't end up having that situation, but watch for it because it's really common. All right, moving on. Here's another one. I think this is a good one for you to like just struggle with for a few minutes. I'll give you a hint. You're going to have a graph. It's going to look kind of like this, and you're going to know the roots like this. And what you're going to struggle with is trying to find the vertex and the axis of symmetry. Just a reminder, the axis of symmetry is not that hard. It just runs right between those two dots. But the hard part is going to be knowing what the vertex is. Now, I'm going to let you struggle with it for a couple of minutes because the research shows that if you just tell somebody the answer before they even think about the question, they won't remember it as well. If you think about how to find that vertex, then you might remember what I show you better. I will pause for a second while you try answering all the questions on this slide. So that is all I have for you.